Okay, seems you're live. Hi, hello, good morning, good evening, wanakkam, assalamu alaikum, whichever part of the world you're joining from. Greetings from DeFi. This is where we are, we'll be interacting with some of the best AI leaders out there who are really making a difference by working on data science models, deploying them in production, and then innovating through it to develop high impact solutions. And when I'm talking about DeFi live sessions, this is an avenue where we invite these leaders with us, and they come and educate us, which is basically the community at DeFi. While we'll be getting started in a couple of minutes, we can wait for a few moments so that others can also join. I can see there are a few people who have already joined on various platforms, but we'll wait for a couple of minutes for everyone to join. So yeah. Also, can people on LinkedIn and YouTube hear me clearly? If that is the case, please comment with a yes so that I can know that you can hear me very clearly. Awesome. So I can see a few yes on. Yep, yep. Great, great. Hi Shubham. Hi Mohanish. Thanks for your comments. Hi Amir. Thanks a lot. Just a quick heads up to everyone who has already joined. We are waiting for a few minutes for everyone to join across channels. So typically we seeing that okay, it's already 8:03 p.m. at my place, which is basically 3 minutes past the time we scheduled for. So we can wait for a couple of minutes and then we'll start off. Okay, cool then. So we'll get started now. Thank you very much for being patient and waiting for everyone to join in. A quick hi to everyone who have joined. I'm Modit. I'm one of the team members from DeFi. With me, I have Vedansh Kedia today, who is a data scientist at UPL. Before I introduce him, I'll give a quick context in terms of who we are for those who are new to our community. First of all, if you're new, a very warm welcome from all of us. I'll probably share my screen to give you a quick context of what we do as a platform. Just give me a moment. So, a lot of you might already know what DeFi is, but for those who do not know, we are a community platform where anybody could learn data science, data engineering, MLOps, data visualization, and related essentials around AI. So, the idea is it's a platform where you can start your data science journey, grow in it, and apply your AI skills to create an impact. And all of this is 100% free. We're an open source community, and we generally grow where people with our community, where every member is willing to learn and contribute in each other's growth. So that's the most beautiful part of DeFi. We have courses on our platform. These are all 100% free that you can take to learn various concepts. Apart from that, there are boot camps running. As of now, I have a really rock solid boot camp upcoming on data engineering, where we are having this boot camp in collaboration with Datadog's Club, where it's been created by someone like Alexi, who's a principal data scientist at OLX, Ankosh, who is working at Shopify, and many more other leaders like them. You can check the syllabus and everything here and register for them whenever before the bootcamp starts, so that you are there when it starts and you can start learning from it. The last bit is the live sessions where we host, people like Vedansh who are willing to contribute to our community. These are live discussions with the top 1% data science leaders out there. So this is the active session at the moment. You can see upcoming sessions as well, and you can register for them beforehand to get nudged and receive a calendar invite and join in when it comes up. So that's a brief intro about DeFi. Now I'll probably stop sharing my screen and I'll talk about our speaker and the agenda for the day. So you know that we're talking about revolutionizing AI in agriculture. Now there's a very interesting term around this particular subject which is called as precision farming, and there are some very revolutionary companies which are working in it. One of such companies is UPL, which is one of the world's largest agri-tech companies, and Vedansh happens to be a data scientist at UPL. Vedansh primarily to being a data scientist at UPL, he has also been a researcher at IT Bombay. He has been a teaching assistant, machine learning teaching assistant at one of the leading edtech companies in India. And interestingly, he was recently also recognized as the youngest inventor ever in the Indian region at UPL. So with his tools that he has been developing in the field of computer vision, geospatial analysis tools, and much more, he has been giving this recognition, and he'll be sharing insights in this particular call, in this particular session with all of us. We'll be talking about various use cases. We'll also be having a code walkthrough. So I'd request you all to stay tuned. If you have any questions, you can anyway put them across. I have a team working with us who will be reviewing all your questions that will be coming up, and we'll be happy to pick them up. Vedansh will be happy to answer them in the session. So yeah, let's get started now. So I'll just loop in Vedansh as well. One second. Yeah. Hi Vedansh, how are you?
Hi,
People can.
Moses. How are you?
I'm good. I'm good. Yeah. So Vedansh, thank you very much for joining us today. I'll probably leave the stage to you for you to lead this particular session now. I'll be there in the back end. Once the Q&A starts, I'll be there with you, and we'll be happy to take up questions from the community. Sounds cool?
Great. Yeah. So now, as you have already given a lot of introduction about me, I'll straight away start with the agro thing. I'll share my screen. I hope my screen is visible to everyone, right, Mother?
Yes, it is visible, Vedansh.
Okay, sure. Thanks. So today the topic that we'll be discussing would be revolutionizing agriculture with AI. So uh, AI agriculture has been always in a footback in all the industries that we would consider till now, especially in India and the other developing countries as well. Now, as in when precision farming as a technology is coming up, people, even the farmers, are looking towards some technological advancements, and they're seeing that they're optimizing their own farms with technology, and they're increasing their trust on that as well. So the topics that we'll cover today would be the some brief about agriculture industry, the factors that are affecting agriculture. So we'll basically analyze where the need of precision agriculture comes in, then its basic usage, what is precision agriculture and its basic use cases, and we'll gradually see elaborate one of the use case of soil nutrition using hyperspectral imaging, and later disease detection using computer vision. So just to proceed, agriculture industry is ever growing now, as in the market value of smart agriculture worldwide is increasing exponentially. These graphs depict that the market size was $9.58 billion when it was in 2017. Then it gradually increased to 12.14 billion dollar in 2020, and it is being forecasted to increase up to 34.1 billion US dollars by 2026. Just give me a moment. Yeah. And yeah, so basically what is the need of this increase in the market size, and how agriculture as a profession is growing these days. Basic factors that affect agriculture are world population, obviously, because as the population is growing, the need of food gradually increases. The land used for farming is also increasing to compensate that particular need. And again, the climate change is a very important factor that is adversely affecting the agriculture, and their precision agriculture comes to tackle those problems. For world population, starting from 1970, it was 3,700 millions, which has now exceeded 77 uh, 94 millions. And this significant growth over the years is creating, I would say, a load on farmers to optimize the yield and get the most of the out of the existing resource. Because ultimately, even if the land used in agriculture is increasing, there are certain limitations. The average farm size is also, as I've just said, average farm size is also significantly increasing gradually through the years. These are certain plots to determine the land increase in hectares in respective countries from 1970 to 2010 to meet the requirements. Then again, climate change is a very alarming topic these days. Carbon emissions are reaching all-time high, and resultant is the CO2 level that has increased from 300 ppm to more than 410 ppm between 1950 to now 2020. And again, it's an unhidden fact that now we are facing even heat waves because of this climate change. And gradually it is having a concatenated effect across all the domains that is again affecting agriculture as well. Now precision agriculture, in very simple terms, it means determining everything with a precision. Everything needs to be exact and based on the analysis of some data, and not just basis of the guess or that we've been doing in agriculture since long. It was a general practice in agriculture. This is my own experience when I visited a farm and I asked a grower that how do you determine which particular herbicide or pesticide you have to spray, and how do you decide that what is the quantity that you decide and the number of cycles. They didn't have a clear answer. Their most like they emphasized on we just see what our adjacent farmer is doing. If there is a rumor that this particular disease might spread in this year, they will do the spray of fungicides on their farms without knowing whether it will actually happen or not, whether the weather circumstances are falling on those lines, whether soil nutrition are going on those lines. Instead of that, they're just doing the guesswork that it might happen, and they spray and they overspray at that times. That results in the increase in cost as well. And definitely, overspraying of chemicals would reduce the yield. That ultimately affects the income. Now, I have kept few slides colorful to just keep things interactive over here. Now, these are certain advantages of precision agriculture. These five listed examples are just a few of the advantages of precision agriculture, and precision agriculture can actually get involved in a very granular level. That is not in the scope of this deck, but yeah, we'll quickly go through these advantages. Crop protection is one very important topic, as in most of the actually all the farmers face this situation where they have weeds or disease or pest in their farms. Pest can destroy the entire farm by either chipping off the crops. Disease is very I would say difficult thing to tackle when it arrives, because it is very difficult to analyze which particular disease is this. The observation would be slight change in the color of leaf, maybe the color of stem, less growth of plant, and it's very important to know what disease it is before spraying a fungicide than just spraying any fungicide. And again, weed creates a different kind of impact. It's a basically weed is an unwanted plant, and it absorbs the soil nutrients which are more required for the crop. And again, that's how it affects the farms. Soil nutrition is uh, it is important to detect the nutrition of the soil. To one major use case of that is to know which particular crop we have to plant in that particular season. Most of you must be aware that there are crop cycles. If one crop is planted in one season, there are a bucket of options, like two or three crops can be planted on one season, and next two or three set of crops can be planted in another season. Now it's a grower's decision that which particular crop they will choose for that particular season. And there it is important for them to know their soil nutrition, because over the period of time the nutrition of soil might reduce because of either excessive spraying of chemicals, or just because the crop has taken certain level of nutrition from the soil. And it can be analyzed either through the chemical analysis, that was an old thing, and now it has been getting optimized with hyperspectral imaging. During this time, I've clearly mentioned that spraying and irrigation management is a important challenge on the farm, because as I mentioned, farmer doesn't know which particular spray they need to do in their farm and in which quantity, how much water they need to put into their farm for the best yield and the fruit size. It has been observed that farmers tend to over irrigate their farms and overspray different chemicals that's harmful. And due to certain statistics, 70% of the water consumed in world goes in agriculture. So it's very important to utilize water and other chemicals effectively on the farms. Weather impact analysis, as we've mentioned, the climate change, and even if we are not talking about heat waves, sudden climate change, storms, or any other thing, uh, just 2 or 3 degree of variation in certain temperature, it's either it's going up or down, can in fact impact the crop yield. Even humidity and other factors are there that are somewhere interrelated with the disease as well. Certain weather factors can impact everything. They can impact soil nutrition, crop protection, everything. So it's very important to analyze the weather. Yield estimation is a topic uh, where after the during the time of harvesting, it's very important for farmer to know how much yield they have produced to sell it in the market, because they sell in bulk, and normally the practice is they sell the entire yield of their produce at one go, and there is no exact measurement of how much yield they have produced. Because let's say if a yield is of let's say quinoa or orange, or it could be named in another ways in other countries. Now there are trees, and there can be let's say quintals of particular fruit in that one single tree. Now it even a small error, let's say of 10%, might affect them heavily, because let's say the entire produce was of 5 tons and 10% would reduce their income significantly. Now, one of the use case that we'll go through is soil nutrition using hyperspectral imaging. We'll not do hands-on on this, but we'll basically understand how it has been done, what's hyperspectral image, and how it can be utilized to know the soil nutrition. basically every chemical or any compound in any of the material has its own property of reflectance. Now, a different chemicals or compounds can be identified based on their different reflectances. A hyperspectral image is actually a image with continuous set of bands, like in normal life what we see in jpg or png images. These are three band images, red, green and blue, or if we go in other around hsv or anything, but these are three band images normally. And multispectral images are the ones which have certain set of bands, the identified set of bands. It can include infrared and one or two more bands, but it gets difficult to know which particular discrete set of band is useful for soil nutrition, because every compound can have a different reflectance. That's where hyperspectral imaging comes in, because since there are continuous set of bands, it is on the analyst or a data scientist to know with either of their visualization or thresholding, however they can analyze which particular set of band is correlating with which particular compound in turn nutrition. So these are few basic steps that can be followed to know the soil nutrition. Basically, uh, one thing is hyperspectral images are, since it's a continuous band, they are very large images with a high number of bands. So first we need to select the required set of bands, and then those particular set of band needs to be reduced, because they would be highly correlated amongst themselves. Hence, we can reduce it by certain dimensionality reduction, or there can be different ways of reducing that particular data, even by taking the averages also, because these are the set of bands. And later it can land into certain visualization and identification. We'll look into this slide for that particular use case. Let's say those continuous set of bands, there are n number of bands, and we tend to identify bands out of it for our hyperspectral imaging analysis. Now, since we have identified a particular m set of bands, we'll take those bands, we can take those bands independently, and these particular set of bands will tend to give us the percentage of every salt independently. Now, we can reduce these particular bands and their sizes by either spatial or spectral browsing and data reduction, spectral data reduction. So spectral data reduction is somewhat reducing the number of bands um, by knowing their correlation. And spatial reduction is, as everyone can know, if let's say if we assume there are x number of pixels on one side, we can reduce it to a certain level. Let's say if over here we see it's getting reduced from 4 to 3, that's a kind of spatial reduction that we can do. Now later that can, till now it was not a cnn architecture where we are actually reducing the dimensions, but later from there we can use a convolutional neural network that can be used to do image segmentation, because one particular image is of soil, and it can have multiple nutrients or multiple salts. So it image segmentation would be an optimal algorithm to be used to know the percentage of that salt. Now that can be used for the as that can be used for all the set of nutrients. Now we'll move towards the next set of problem statement, that would be disease detection use case. What we'll look into it today would be to fetch the data, explore the data, what data has to offer us, and data augmentation would be there, removing duplicate data, filter, like it will be all set of pre-processing techniques, and at last we'll create a model, and we'll use transfer learning and train a model. So I'll just close this uh, deck and move towards the other part. Okay, now to fetch the data, it's a Now, the problem statement that we are looking towards is a Kaggle problem statement, because that's what I could share right now as per the policies that's cassava leaf disease classification. The data is available on Kaggle, and naturally certain notebooks are also available. As it was a competition, we can quickly fetch this data for our analysis. As I already have this data, I'll switch to the code part. So wait, I'll first look where my code is.
Okay, while Vidansh is finding the
Yeah.
code, yeah,
No,
you've
no.
got
The
awesome,
code
awesome.
was there. You just had to switch the windows.
Okay, great, great, great. Yeah. So just wanted to say that if people have any questions based on what he has already shared, they can start putting it up. Our team will be happy to, start curating them. Yeah.
So as per that pipeline, we'll start with the data exploration part, where we can firstly install certain required like packages. These are basic packages, and I hope that would be already installed in everyone's systems. That's sklearn, Seaborn for certain visualizations, and of course OpenCV, as we'll be processing the images. So we'll import those set of libraries, and that particular data has a certain format. I can share the kind of format it already has. Uh, so this is the format of the data where they share the test images, test TF records, train images, and they share a train CSV. They have mapped the labels and the images on a CSV, and the remaining files would be added during this code, uh, when we run this code. So I'm just taking a sample data over here. I just ran through these cells using a sample data because there was a time crunch. Uh, Running those cells might take certain time, so we'll just quickly go through it likewise. The next step that we'll take is we'll observe the imbalance in the data. That is basically the count of every category, the count of images in every category, and how much imbalance it creates in our data. So it's a problem statement with 5 category of diseases in cassava plant, where the third particular category, or I would say this is the fourth category, that is creating the most amount of imbalance, where it has around 13,000 images, while other are lying under 2,500 images. We'll just quickly take a sample of that data that we've already considered over here. I'm just considering 10% of this data to do this exploratory analysis. Then we'll just quickly fetch some basic info, that would be the class names. They have a particular JSON where they have mapped class 0 with the category name accordingly. So that can be looked at later. And accordingly we'll just quickly map the class names, and we'll ultimately load our data into the numpy arrays. We'll load all the images and labels in separate numpy arrays over here. The basic idea that we are following is we are iterating through that entire data frame, and we are just reading it into a numpy array. We load those images and labels over here. We just get to know the shape of that particular data set. That's 625. So approximately there are 6,000 images in that data set. We'll shuffle those images, and yeah, we have resized the image to 300 cross 300, so that it's better for our analysis. And more optimized for the model that we are going to use later to fetch a feature vector. Now, as a next step, when we are fetching the feature vectors, we can use multiple models for that. Over here, I am going to use Inception v3 that's pre-trained on iNaturalist. iNaturalist is a kind of data set that's trained on certain set of plants or animals. It's on us to choose whether we have to train a model for a plant or a animal. We've taken the plant one over here. We'll fetch that particular layer. The second option could have been VGG16, but I'm not going to use that right now. We'll just create a simple architecture over here that it's a sequential model where we are attaching that particular Inception v3 model, flattening the output that it returns, because we are not going to include the top. It is just going to return us a feature vector over here. And we'll pass our train images array, numpy array, to get the entire set of features from the data set. And as we can see, it is returning a vector of size 2048. We'll fit that model to our SVM, and just we'll get to know the score of our SVM over here, because it's a linear coordinates to be fit on. Then what we'll simply do is principal analysis. Our end objective over here is that we'll just observe a basic plot to know how much interrelated the properties are of a particular image. That's our end objective over here. So we're just reducing the dimensions down to 2, because over here in Jupyter Notebook right now we can display in 2 dimensions only. We can utilize other tools as well to view in 3 dimension. But at the end, if our feature vector was in 2048 size, then it wouldn't matter much if we reduce it to 2 or 3. It's anyway very less. And when we'll do that principal component analysis, just to brief about principal component analysis, let's say if we have certain set of plots, and it what basic objective of principal component analysis is to, if we analyze a plot over here, we can see that it's a kind of going towards the left. Just imagine if it was a 2 dimensional data itself, then it will fetch and if we have to reduce the dimension down to 1, then it will fetch a linear line over here, which uh, is having the minimum error, I would say the mean squared error, through all those points that we can see over here. That's principal component analysis. I hope, like, I didn't have a visualization for that, but I hope that was clear. So that's how similarly we are reducing this 2048 dimension to 2 over here, and we are observing these particular set of plots. We can change these numbers to just observe the relation, the spatial orientation of different classes. Right now, right now we are seeing the orientation between first and the fifth category, as in the second and the fifth category we're looking at right now. We can look at the first and the fifth category as well. Right. So there will be a certain level of basic observations that certain, if one will be able to observe more blue lines are on the bottom left part and more oranges are on the uh, top right corner. This just aligns for the spatial orientation and nothing much. We'll quickly move towards the data augmentation part. Now we'll just import these certain set of libraries. These are very common ones: the TensorFlow, OS, Glob, Matplotlib, Seaborn, and so on. We're taking the original image size of 600 cross 800 over here, and we're just fetching that data. We've already seen the level of imbalance in our data, where the fourth category was having the highest number of images. Again, we've taken a fraction of these images over here to just run this notebook quickly. I took that fraction, and just to know the numbers of every category, I have printed the quantity of images in every category over here. Again, we can see the fourth category is having the highest number. Now there is this balance function that helps us to understand how much skewed a particular data set is towards any class, and what needs to be done to balance that particular data. Over here we are using a linear function for that, but we can have logarithmic. During data augmentation, we didn't need it logarithmic, we can use it while training a model. I'll explain that later. Basic objective is we'll see the amount of images that we have over here, and what weight we need to assign over here in case of data augmentation. How much, what's the multiple that we need to have? Let's say if there were 122 images in category 0, then we have to get that number multiplied by 10, like those number of images that we need to augment to have the best balance in our data set. That's the objective of this balance function. I've just created a layer of data augmentation using keras.sequential, where I'm just doing a random flip, that's horizontal and vertical, changing the contrast, just doing some translation. Translation is the kind of horizontal shift that happens to a particular image. Random rotation is to a particular degree, zero point 0.1. It happens in radians. So randomly it will be rotated between 0 to 0 0.1 radian, and accordingly it will be random zoom. This is just to have the maximum variation in our data set. And then using that data augmentation layer, I have passed all our images over here during an iteration, and have ensured that, let's say if a image of class 0 is passed, we tend to get 10 images out of it, and save it in our data set to generate that particular balance in the data. And at last that particular set of images are stored in a, like, the mapping is stored in one of the CSV using this particular set of code, where I'm just traveling through the set of images and the label they are assigned to. It is possible to slight extent that a particular set of images gets duplicated. Now, just for a sanity check, it is important to remove the duplicate images from our dataset. The basic algorithm that we are going to use is by hashing the image. I hope everyone knows this already, that a particular set of information is, when hashed, has a unique hash hex code. Now, if two images are different, they will always have a different hash code. They can't have a same hash code. Similarly, same images will have same hash code. That's what we are going to use over here to compare between the two set of images, so that this process is fast and we don't have to compare each and every image. Because if we'll just quickly observe the size of a particular images, 600 cross 800 into 3, it will be somewhere in tens of thousands of pixel, and that much of iteration will never actually end. So this is the function to remove the duplicate, where we are reading all the images over here, and reducing it down to a hash. And then we are just doing a hash, we are just comparing that hash. If it's a basic algorithm of hash map. If there is a collation, we get to know that the hash already exists, and it is, that particular hash is now, that particular index is added to the list of duplicates. And that's how this check is ran through the entire data set. Later, those images are removed from our data set using this particular set of code, and some random or duplicate files are printed on the go as well. That like removal would be here, and some duplicates can be shown over here during some subplots. And then this is a final sanity check where we'll get to see that which was the working directory, the total number of images, and how much duplicate images were identified. Naturally, if we'll run this particular cell multiple times, then the duplicate images are already removed, so we'll get the count as 0. Now, to move ahead over here, now since we don't have any duplicate images in our code, we can move towards training our model. We can skip this import library part. We can just double check if you have the GPU in your system, then it is live or not, it's getting utilized or not. It's a quick check over here that the TF is built with CUDA or not. Now, since we have already augmented that data over there in a different scenario, we don't need to augment the data again over here. There's an alternative approach that we can add this layer to the model architecture itself. So whenever a batch of images are fed to a model, then it automatically does all these transformations and pass it uh, to the supposed to be the best base layer. But since we had to train if in case we have to train the model multiple times, then by having such an additional layer of processing while training the model, we can just augment the data set and improve the balance in the entire data set at one go itself. Now again, the data is being fetched from that CSV. We are reading that data from CSV, and again, now here comes the balance function. Here, balance function is most used because now it will actually affect the training. The role of this balance function will come where we'll be updating the weights in our model. Now, since we have corrected the balance in most possible way, we can observe that all the values are close to 1. But over here, when we were augmenting the data, we could see the kind of imbalance we had in our data. Let's say if we wouldn't have done this data augmentation over here, then this would be the imbalance values that we would have had in our data set, and accordingly the weight updations would have been done. Now over here we can see that just to go on a granular level of this balance function, it's basically the amount of values we have in that particular category divided by the kind of that like the amount of images we have in that category divided by the maximum amount of images in our data set in any of the category. This is one way of calculating a balance, but while we are training, the better way can be it depends on some trial and error. Normally we'll get a lesser loss by having this another line where we are using a logarithmic function, because we don't want a model to just move around the global minima and don't reach that, because the values over here, the balance values over here would be pretty large, and it will be rationalized over here in the logarithmic function, and it improves the model training at times. Now okay, so this is just we're just loading this data. We're just creating a generator over here. It's a kind of an iterator through which the uh, model will traverse for training. Then the feature extractor layer over here will fetch this particular model from TensorFlow Hub. Again, over here, it's Inception V3. It can be different. We can fetch a number of base layers from there. It can be ResNet, it can be BGG, MobileNet, can be pre-trained on ImageNet, right? but I preferred iNaturalist over here. Basic objective is to extract the best possible features from our image. It can be tried whether it is done by ImageNet or iNaturalist over here. Selecting an architecture has a better way. We'll not get into it today. So we have just determined the strategy over here for model. We can see it's a kind of mirrored strategy to utilize the GPUs and CPU in a better way. That we'll just use that in scope and compile our model using that. This is our model summary. This entire inception model is mentioned over here as a layer because we've added it into a sequential layer right now. Now, now it to better train a model, we need to have a set of callbacks determined to observe where the model training is going and how it can be optimized on the go. Obviously, observing the learning rate and the accuracy is one thing where we can see how much accuracy we are getting in a particular epoch and whether we have to stop the training, continue the training, if we have to change anything in the next iteration. But it can be done gradually. Let's say if we have to reduce the learning rate, we can create a decay function over here and just simply determine if the number of epochs is less than 2, then what should be a learning rate, and if it increases gradually, all that can be determined in this decay function, that what learning rate we want in which particular epoch. The criteria can be changed. It can come to accuracies also. We can see, or it can go to if we can have a determined function where it can judge that if the accuracy, the validation accuracy and the training accuracy is this much, if the model is overfitting or if it is underfitting, if we have to change the learning rate, that can be done as well, because it's just a parameter that it is comparing to, and we can assign that parameter to our rate learning rate scheduler in our callback, and pass that particular callback to our model. Now, this particular statement over here, model checkpoint, will actually save the model if it if in any iteration the accuracy improves. It will save the model in every epoch. So if in case someone observed that he has scheduled a training for, let's say, 20 epochs, and somehow he has reached a decent accuracy on 10th epoch, but further to that model is not performing well, so rather than gradually training, he can stop the training in between and save the model and save the checkpoint. And at last, this is the model dot fit function where we are training our model by passing our train generator, validation generator, epochs, and the callbacks that we have defined just over here. And the accuracy can be observed over here. The process can be observed over here. Now, obviously, if I have trained the data on a 10% data set, it didn't have the best accuracy, but highest that I've received over here is 91 point some percent accuracy was achieved when it was trained on the entire set of data. Then again, this now there comes the part where we have to analyze our model training. Now the metrics are being stored in this history variable over here, because metrics are returned by this model.fit function that's stored in this history variable. Now we can quickly plot that particular metrics over here. The most commonly seen metrics would be the loss and the accuracy. So we can see over here the accuracy has uh, the model could have been better by if we increase the sample size of data, of course. There is a certain set of training accuracy and the validation accuracy, and accordingly the loss is getting reduced and can be visualized over here. And we can observe how our learning rate was changing gradually across all the epochs, where it started from 10 to the power minus 5 and ended till 10 to the power minus 7, just to fine tune the training uh, on the later stages. to reduce the loss. And then we can also have a confusion matrix where we can plot our last validation generator batch. We can have a prediction for that, and can be visualized as a confusion matrix. The best confusion matrix would be where uh, the numbers on these diagonal left diagonal are on a brighter side, and the remaining is on the darker side. And if in case we are running a lot of notebooks, this garbage collector can collect the things. That's an optional thing. No. Yeah. So that's all about the code run through. Yeah. So if anyone has any kind of question, it can be.
Yeah, thanks a lot, Vedansh, for that absolutely hands-on and insightful presentation. There are a few questions that people have asked. I'll probably start picking them one by one. I'm not sure what Yogesh implied by this. Probably if you can answer, or maybe Yogesh, if you're there, if you could, clarify in terms of what you want to understand by pricing of the product. Probably,
Which product
mm,
are we talking about over
y-
here?
yeah. I'm, Yogesh, if you could maybe probably comment, that will be helpful. Meanwhile, I'll pick the next question that we have curated. That is by Gulab. He's asking how would you do the real time leaf disease detection using drones with CV?
Okay, so over there, the method changes slightly. Instead of images, we are having videos, but at the end, even the videos are the frames and the analysis are done over the frames. In case of drones, there can be certain alternative ways, like instead of using RGB images over here, there we can even use multispectral or hyperspectral, because again, even the diseased leaf is having, like not well leaf is having a different reflectance, and it can be analyzed through those set of images. What I'm saying about multispectral or hyperspectral, because drones fly at a higher altitude, and it might get difficult to capture the details from RGB image of the leaf. So those kind of images might help, and you can use the similar kind of analysis that I've shown for the soil moisture that can be utilized over there to identify the diseases as well.
Okay, thanks for that answer. I'll probably pick this next question, which is fairly. So a good chunk of our community members are recent graduates who have been working for around 2 3 years, and it's a question that will a lot of people might have. So I want to pick this one. So Sanjana is asking how what's your recommendation to a recent grad who's looking to transition to a data scientist role. Again, this depends on what somebody's doing at the moment, but yeah, maybe you could give a generic answer for a software developer, maybe.
There are n number of options right now to enter into data science, because honestly there is no entry barrier over here. What you need to have, you don't need to have a certain set of degree to enter into this domain. There are different courses that you can opt for. There are a number of certifications. Either it can, the entry level certification is the TensorFlow certification. Using that, you can absolutely enter into this domain, because that certifies you for a particular knowledge. That's it. And obviously you have a number of courses on Coursera, Udemy, and further.
Yeah, and there are courses on DeFi too. Uh, that's just a shameless plug here, but yeah. Thanks for that answer. I have a very quick follow up question here. In fact, this was, by the way, mentioned by in one of our recent sessions with Bob Friday, who was from who's a CTO at Juniper. Even he mentioned that he prefers to hire recent grads and people from college because of certain traits that they come up with the energy and the kind of conceptual knowledge that they might have. But one common perception that a lot of community members have, it's something that we have seen a lot of times, is that generally entering as a proper data scientist in a particular company would require someone to do at least a master's or a PhD. So, uh, I mean, what would you comment on that? What's your recommendation to, let's say, somebody who's just a bachelor's, for example?
see bachelor's works these days, and masters will add a kind of certification to your a degree to your thing. So naturally that will give an edge. But what data science requires the most is that aggressive nature to dive into the data and do certain level of analysis. And that's the key thing. And you have a lot of resources available. You can go through those set of resources and enter into this domain. Yes, masters could be a kind of entry barrier in certain organizations, but not all.
Okay, I think we are almost done with our questions of this particular session. So yeah, great. Then so I think most of the people had questions around this, which you have answered in some other way. So yeah, so I'll probably thank. This is where I thank you for being with us today, and I think it's me speaking on the behalf of the community, but we really appreciate the kind of effort and the detail you have explained with. Um, I'm pretty hopeful that it will help people in terms of applying the concepts in their real life. Is there any other? Okay, there is one question that Alan has asked. Okay, before ending this up, but okay, probably you can answer this before we wrap it up. Where can we find good data sets related to agri? And this is something that I think when you were discussing, you also mentioned because what happens is we recently even we hosted a particular AI challenge on the lines of World Data League, which had a problem statement around pest classification. And one of the most common problem statements that I was emailed was, from where did you get the data set, or how do you get a clean data set? So, what's your answer to it?
There can be a lot of different kind of data sets in agriculture. We have to be clear on what kind of data set we are looking for. But just to say, let's say if we are looking for some satellite images to do that level of analysis, then there are certain platforms, let's say Landsat, Esri, they offer free images to a particular resolution. Like in satellite image, resolution works as, let's say, 30 centimeter, 1 meter, 2 meters. Likewise, the resolution is there. 1 meter resolution means 1 square meter in 1 pixel is the kind of resolution. If I mean resolution is 1 meter, then and they offer free satellite images for the size of 10 meter. That's good for a kind of generic analysis if you need to learn something from that data set. And now there can be different data set for analyzing the soil. I'm not sure. Data set is a challenge in agriculture. I'm not sure about the soil nutrients, but uh, let's say if we have to analyze any other thing, what we were looking at, let's say images, there are iNaturalist is one place where you can find the data, because since they've trained, the data is also available. And yeah, weather data is available on weatherbit.io, and there are different platforms for that weather data as well, where you
Okay.
will get 6 months forecast and even the history data to do the analysis.
Okay. Thanks for sharing these resources. I think it's pretty, descriptive in nature. There are folks who have, thanked you, including Alan. Uh, he's one of our most active community members. But yeah, so thank you so much, Vedansh, for being with us today. Really appreciate, you spend the time with our community. I hope you enjoyed it because the community loved it on their behalf. And I'm sure it will really help them in terms of implementing solutions in the agri sector. It's something which is even we at DeFi are very passionate about in terms of the impact it can create. So thank you so much, Vedansh, for being with us today.
Thank you for inviting.
As we wrap up, I'll probably talk about one important thing which is coming up on DeFi, and I would probably request for you all to hear me out on this one. So we had Vedansh who was with us today, who's a pretty seasoned data scientist who was willing to share his learnings in terms of how you could apply data science in the field of agro. We have a couple of other things which are coming up which may interest you a lot, so I'll quickly share them. So this is a session that we have. Okay, this is a session that we had with Vedansh, who is a data scientist at UPL. I think I got the name wrong there, but yeah. Uh, but so this was a session that we had today. Every week we'll be having one such session where we'll be inviting someone like Vedansh will be coming and educating the community. So next week we have Supreet Kaur, who is an assistant vice president at Morgan Stanley. and she's also a founder of a data science community called as Databus, which is on 14th May, same time, same place. You can be here, and you can register for it beforehand so that you receive a calendar invite. Apart from that, the next session that we have is on 18th May, the very same week, with Alexi, who is a very dear friend of ours and a principal data scientist at OLX Group. So he'll be talking about claims prediction. Okay, I think. Okay, so he'll be talking about, I think, different topic. He'll be talking about data engineering. I think I got the topic wrong. My bad. But he'll be talking more on the lines of data engineering. You can probably check out the session here on DeFi's website. So all of the sessions are available now. You can go ahead and register for them. Yes, the topic is machine learning on streaming data. Talking about streaming data, there's also a bootcamp ongoing, which is it's a 9 week bootcamp which has started. It has various parts to it. I mean, it starts off with very as basic topic as introduction to data engineering. Then you will have data ingestion, warehousing, analytics engineering, batch processing, so on and so forth. And it's pretty much hands-on in nature. So you actually get to work on DCP, Postgres, Docker, Kafka, Airflow, and other tools which are very much needed. It's created by Gita Talks Club, which is our very dear partners who has been helping us from our very initial days. And last thing that I want to talk about is this particular AI challenge that is happening on DeFi. It's around it's a data sprint that is happening where a real world data set around airline passenger satisfaction is being uploaded. You can go ahead and check that out. It's around developing an ML model that can predict the satisfaction, can determine the satisfaction of a particular airline because it's one of the key driving factors in the industry. So that is pretty much from my end, and would really love to see you again 1 week down the line. It was great having having you all today with when we were hosting Vidansh. Thank you so much for joining in. See you soon. Bye. Take care.